Let's go to page 264. This is lesson 4.7, and this is about to learn how to use isosceles and equilateral triangles. So in lesson 4.1, you learn that a triangle is isosceles if it has at least two congruent sides. So when you have two congruent sides, then this is an isosceles triangle. When an isosceles triangle has exactly two congruent sides, these two sides are the legs. Okay, so again, when you have two congruent sides, then these two are called legs. The angle formed by the legs, the angle formed by the leg is a vertex angle. So the top on the top, this is the vertex angle, and the third side is the base, and these are the base angles. Okay, so again, the third side is the base of the isosceles triangle. The two angles adjacent to the base are called base angles. So when you have a triangle that have two sides are congruent, okay, so in this case, this would be isosceles triangles. And the angles on the top of here, this is called the vertex angle. And this would be the base, and this would be base angles. Okay, now let's go through some theorems. So theorem 4.7, the base angle theorem, it says if two sides of triangles are congruent, so if two sides of a triangle are congruent, then the angles opposite them are congruent. Okay. So it says if AB is congruent to AC, then angle B is congruent to angle C. Okay. So the way to remember is that the angle facing congruent sides are congruent. So again, the angle facing the congruent sides are congruent. So that's what that base angle theorem is. Okay. So instead of memorizing the name, you can write down the content. Okay. So in this case, you can write down angle B congruent to angle C because angles facing congruent sides are congruent. Okay. So that's what we're going to use. And this one's going to be kind of the similar to that, the converse. Okay. So this is converse to that. The converse of base angle theorem. If two angles of a triangle are congruent, then the sides opposite them are congruent. So it says if angle B is congruent to angle C, then AB is congruent to AC. So what it's saying is that the sides facing congruent angles are congruent, or the legs that are facing congruent angles are congruent. Over here, the angles facing congruent sides are congruent. Over here, the sides facing congruent angles are congruent. Okay. So again, instead of trying to memorize the name, you can just write down the content. Okay, so let's apply the base angle theorem. In triangle DEF, so DE is congruent to DF. Okay, so see the marking. So then the two congruent angles. The answer would be angle E is congruent to angle F, because angles facing the congruent sides are congruent. So angle E is congruent to angle F. Okay. Okay, so over here, this is a proof for base angle theorem. Okay. So let's go and go through the proof. Okay. So I'm going to just go through the proof so that it's easier to follow. Okay, so you are given JK is congruent to JL, and you want to prove angle K is congruent to angle L. Okay, so over here you have this picture over here. Okay, so giving the JK so JK, they use a 2 hash mark. So JK is congruent to JL. Okay, so basically, you start with the isosceles triangle, and so you draw the angle bisector. So let's see. So it bisects KL. Bisects KL. Okay. So you have a triangle, okay, and the given is these two are congruent. So what you need to do is you draw the additional line over here. So basically what you do is you find a midpoint. Okay, this is the midpoint. M stands for midpoint. So you draw from here to here. So you can wherever this segment is, you find a midpoint and you draw the line. So that's congruent like this. Okay. Okay, so let's go and do the proof. Okay, so you draw the midpoint, right? So 1, M is midpoint. And this is the definition of midpoint. So this is kind of really detailed. Okay, so most of the proof don't start with like nothing over here. Okay, so again you get the point, midpoint, and then you draw JM, and the reason for that is any 2 points can determine a line, right? Okay, again, you can use a lot of abbreviations. Okay, so 3 MK is congruent to ML. Okay, and this would be definition of midpoint. Okay, so again, this is more midpoint, so when you draw that, this would be congruent, and that's a definition of midpoint. Okay, so now we're getting somewhere, okay? Now remember, when you have two triangles butt against each other, you're always looking for reflexive, okay? So number 4, yeah. So JK is congruent to JL. So this one is it takes a while to get to the given, okay? So normally the given, you do it in the beginning, but because this one you want to prove a theorem, so you kind of start from nothing, basically. So you have to do a lot of all these little things before you even get to the given, okay? Okay, so this is given, so that's what you have so far. Okay, remember what I said, right? Whatever is, after you use up everything, you're looking for, when the triangles are butt against each other, you look for reflexive. Okay, if you have like this kind of situation, you're looking for vertical. When you have this kind of situation, you're looking for vertical angles. Okay, when you have this kind of situation, you're looking for reflexive. Okay, so you have JM is congruent to JM, and this is reflexive. Okay, so then after you do it, you do the markings, right? So now you can see that the triangle JMK is congruent to triangle JML, and this would be SSS, right? So again, that's why it's important to do the marking, so you can see what theorem you need to use. Okay, and then after that, angle K will be congruent to angle L. And the reason for that would be CP, CTC, okay? So now you can see angle K will be congruent to L, okay? And that proves the theorem. Now angles facing congruent sides are congruent, okay? Okay. Okay, let's go to the next one. Okay, so the corollary is additional facts. Okay, so if a triangle is equilateral, then it's equiangular. Okay, so equilateral means all three sides are congruent. So if a triangle, all three sides are congruent, then all three angles will be congruent because, again, the angles facing congruent sides are congruent. So since all three sides are congruent, all the angles facing them will be congruent. And the converse is also true. If a triangle is equiangular, then it's also equilateral. Again, if all three angles are congruent, then all three sides will be congruent. Okay, example 2. Find measure in a triangle. So find the measure of angle PQR. Well, if all three sides are congruent, then all the three angles facing the congruent sides are congruent. So all three angles are congruent. And remember, the inside of a triangle, the sum of the angle will be 180. So if all three angles are congruent and they add up to 180, so that means if you call this x, so you got x, 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 right? So you got 3x equal to 180, you divide by 3, so x will equal to 60. So all this angle will be 60 degrees each. Okay. Okay, so now let's go to example 3. It says find the value of x and y in a diagram. Okay, so this is do a little bit of algebra. So to do this kind of problem, okay, so let's go ahead and do this one. So I'm going to draw a big triangle. So this is K, N, M, and this is L. Okay. So you're looking for x, right? So the way to do it is you just look at diagram and just apply your theorem. Okay, make sure you draw your picture big enough so you have room to write. Okay, so first you notice all three angles are congruent, right? That means all three sides are congruent. So this will equal to 4, and this will equal to 4. So right away, y equal to 4. Okay. Now also, if you notice that these two angles are congruent, okay, so the two sides facing the congruent angles are congruent. So that means these two are congruent. So 4 equal to x plus 1. So minus 1 on both sides. So x equal to 3. And that's it. So x equal to 3 and y equal to 4. Okay. Okay. Now let's go to example 4. It says lifeguard tower. In a lifeguard tower, it says PS. But this one solve a multi-step problem. Okay. So you have. So this one you don't really have to do a proof. Okay. So this one you have the P, Q, S, R, T, and this is 1, 2, 3, 4. Okay, and it says PS is congruent to QR, and angle QPS is congruent to angle PQR. Okay, so sometimes when the triangles are overlapping, sometimes it's very confusing to some students. So sometimes it's a good idea to kind of separate the two. So that this is P, Q, S, and this would be P, Q, R. Okay, so kind of sometimes it's good to slide open so the two will not overlap. So this is angle 1 and this is angle 2. Okay. Okay, so slide the two open. Okay. Now, next also remember when you have something like this is reflexive, right? So this, wait, equal to that, right? Okay. So from here you can see that two triangles are congruent because of the SAS. Okay? So two triangles are congruent because of the SAS. Okay? So once you prove that the two triangles are congruent, then you can use the CP.CTC to prove everything. Okay? So now we can answer the question. Okay, what congruence project can you use to prove that the two triangles are congruent? Well, the answer is SAS. Okay? And explain why PQT is isosceles. Okay, why is it triangle isosceles? Okay. Okay, well now you know that angle 1 and angle 2 are congruent, right? So if you go back over here, so these little tiny angles over here are congruent. So you can see the angle 1 and angle 2 are congruent. Therefore, this triangle right over here is congruent because of that. Okay, it's isosceles, right? Okay. Explain why PQT is isosceles, because angle 1 is congruent to angle 2 because of CP.CTC. Okay, so sometimes you have to go back and forth between the two pictures. Okay, and it shows that triangle PTS. So PTS. So now you have to show that triangle PTS is congruent to QTR. Okay, so in this case, again, because see over here, now you can use a CP.CTC also when you're done using it, right? Notice that you can see that the angle 3 and angle 4 are congruent, right? Angle 3 and angle 4 are congruent. Oh, we didn't put it over here. Okay, so we can see that angle 3 and angle 4 are congruent. Okay, and also remember when the corner to corner, remember what I said about using the vertical angles, right? So you can use the vertical angles are congruent. Okay, so run out of kind of a lot of arc. Okay. Okay, then now you can prove the two triangles are congruent because of the AAS, right? AAS. Okay. Okay, so again, this one it does not ask you to do the complete proof, but from here you can kind of use the logic, right? But the key thing is you can separate the pictures and do the markings, and you can just use all the theorem you know and just kind of do it step by step to get that. Okay.